This is stage 2, lecture 2.2, slide number 27. Determination of rate constant with respect to decomposition of hydrogen peroxide. Now, hydrogen peroxide decomposes as H2O2, giving 2H2O plus O2. Sometimes volume of the reagents given in volumetric analysis can be determined directly or indirectly with respect to the reactants, provided V infinity is not given. So let me make you clear that when hydrogen peroxide is decomposed, availability of hydrogen peroxide during the experiment can be done provided hydrogen peroxide is titrated against KMnO4. Now in this reaction, KMnO4 is a oxidizing reagent and hydrogen peroxide is a reducing agent. Okay. Now, in the decomposition of hydrogen peroxide is titrated along with K2Cr2O7 and KMnO4 in acidic medium. Because only in the presence of acidic medium, hydrogen peroxide acts as a very good, strong oxidizing agent. Now, we will be able to use this formula K is equal to 2.303 by T log V0 by Vt. So V0 is the volume of the reagent used at 0 time or before the start of the experiment. Vt is volume of the reagent used at time t. But here V infinity is not given. What is V infinity? V infinity is the volume of the reagent. It is the volume of the reagent which corresponds to initial volume of hydrogen peroxide. Already we have discussed here, initial volume of hydrogen peroxide is V0 and Vt is at time t. So by substituting the various values of V0 and Vt, if we get the K as rate constant as approximately the same value, then we can understand that hydrogen peroxide decomposition represents first order kinetics. Further, the rate of this first order reaction is measured by titrating a fixed volume of hydrogen peroxide. Fixed volume of hydrogen peroxide is undecomposed hydrogen peroxide against a standard solution of KMnO4. Hence, so here KMnO4 acts as an oxidizing agent and hydrogen peroxide as a reducing agent. Therefore, for various values of T, various volumes of KMnO4 will be used and tabulated. Once we get the same values of rate constant, we can ensure that the hydrogen peroxide decomposition is representing a first order reaction.